go get your building kit. I have to do a lot of things. Here. There. All right. So we start our first project of the year here, and we're going to be doing this one here, the bridge. So the purpose of this activity is to, first of all, get some experience with engineering design, but also to get some experience with kind of engineering economy. What I mean by engineering economy is that you can't just go off and build something and just use up all the materials that you want and use up all the resources that you want and expect it to be cool. I'll give you an example. I had a student last year who was taking this class, and when I asked them to build a bridge using this guide, this activity guide, he just went ahead and used just about every single piece of wood in his build kit and glued together a platform of just wood. He just layer upon layer of wood, so it was just like a 2x4 when he was done. And it was an extremely strong bridge, but in the real world you can't just pile up steel beam upon steel beam upon steel beam until it's strong enough. That just can't be done. First of all, it would cost way too much. Bridges that have 1,000,000 tons of steel in them are just way more expensive than a bridge that has 250,000 tons of steel. They literally cost 4 times as much, right? And you just can't do that. You're not given an unending budget to build bridges. Second of all, the material itself has weight to it, and steel weighs a lot. And so a bridge built like that in the real world would have collapsed upon itself ages ago. Wood has a very low weight, and it has a very high strength to weight ratio. And so you can actually build bridges out of wood, just piling planks out there, gluing them and bolting them together. You can do that, and it'll be a very heavy and inefficient bridge, but it'll be strong to work well. But it won't be able to go very far, it won't last very long because the wood will deteriorate. You won't be able to span a very long distance. And so it's not very efficient engineering design. Our objective here is to learn not just how to build something, but how to design something so that it is efficient. It's an efficient use of time, energy, materials, and money. So you can see here that our bridges are not just solid planks. They've got several different varieties of bridge. They've got a truss. This is called a truss bridge, right? This one, these two are called arch bridges. One with arch with cables, one arch is with members. This one here is a suspension bridge where it has an inverted arch that the bridge is suspended from, but it also has a truss element underneath. The trusses being these triangular elements that add strength to the structure. And you're going to have an opportunity to evaluate different types of bridges, different bridge building techniques, to design your particular bridge that you're going to use, and then, of course, in the end, to build it. So in your kit, you have most of these materials. You have a whole bunch of strips of wood. It's usually 10 standard, so it's these ones here. And yours are much shorter than the ones they're showing there. But I've given you a lot of them. I think I've given you over 100 of them. But you're not going to use them all on the bridge because this build kit is supposed to last you throughout the semester. We've got several projects to do, and you're going to use them on every project. You have these dowels as well. They say 10 dowels, and I don't think I give that many, but I think I gave you 8, and so you're not going to have enough to use all of them on this project. Once again, you're going to use them on other projects. You want to use as few as you possibly can. I can give you more of these materials as the semester goes on, so don't be too worried about using up parts. If you need them, use them. But if you're just putting them in there to make things easier on yourself so you don't actually have to design, I wouldn't recommend that. Plastic connector strips, that's this part right here, these plastic pieces. And then there you have steel wire. I'm not providing you with any steel wire. I have provided you with string. The string will do the same thing. It's strong enough to do anything you need to do for this bridge. I've also got glue for you guys here. For our distance students in other areas, just use a standard wood glue. I wouldn't use the white school glue. I would use a wood glue from a store, like an Elmer's wood glue or a Type Bond wood glue. And I wouldn't use some of these fancy things like the Gorilla paste or construction adhesive. Those things are not as strong as wood glue with wood. The strongest bond you can make with wood is with wood glue that is designed specifically for wood. It's even stronger than using screws in wood. So it's a very, very strong bond. The wood will break before the bond breaks. So that's how strong it is. And then there are some other supplies that are included in the kit that you can use if you want. For the bridge, you don't necessarily need them, but there are some machine screws and nuts and bolts and rubber bands and other things like that in your build kit that you will use in other projects more than this one, but they are there. And if you decide that you need them in your design, go ahead and do that. That's fine with me. But that's kind of where we're starting with the supplies that you've got. Now, tools in your kit, I have not provided you with a scroll saw or a drill press. But if you want to come and use my tools, you can. I do have drills. I don't have a drill press, but I do have a drill. And I think I provided a number 3 drill bit in every kit so that you could use your own drill at home if you want to. And these things are actually quite easy to cut. You don't necessarily need any kind of saw, an electric saw like this. The plier cutters, little hammer and anvil cutters that I provided are really good for cutting this wood at different angles and very precise. Doesn't ruin the wood at all, so they're great for that. If you need any other tools that you don't have, come talk to me. I have lots of tools. I'm willing to let you use them. You just need to ask. Now, how is this going to go? The whole purpose of these projects is to teach us the engineering process by doing it. Now, we've already kind of discussed a little bit about the engineering process. And there's lots of different ways to discuss the engineering process. This way is actually quite a simple method, and it's just a simple cycle. Right here on page 3, and I will provide each one of you with this worksheet. I will send it to you in an email. And it will be your responsibility to follow this guide and also to fill it out. There are parts of it that you will actually fill in things, draw things, and so on and so forth. But your engineering design process is really quite a simple little cycle here. It starts here at the top with a problem statement and design brief. What is our problem? What are we trying to do? What is it? What is the need we're trying to fill? Right? In this case, we're trying to build a bridge, and there's going to be some specifications in here. For example, the bridge has to span a certain distance, has to hold a certain amount of weight. Okay? And I don't remember what they recommend here, but I think that I said that I liked the idea of 2 feet and 10 pounds, or was it 2 feet and 20 pounds, or something like that. We'll go with 2 feet and 20 pounds. Your bridge will have to hold 20 pounds, and it will only be allowed to be connected at the end of a 2-foot span. So no other connections to ground or anything else in those 2 feet. And that's kind of your problem statement, to build a bridge out of these materials with as few materials as possible. That's another thing that we're going to always try to do, is to be as efficient as we can. And then be able to hold 20 pounds. Now 20 pounds is a fairly significant amount of weight. So you have to take that into account. After you've figured out your problem, you've got a statement, you've written it down, you've got some details, some specifications, then you start going into investigation and research. What are the possible things that we could do? You may start out simple and then research more and more complex things. And that's what I would recommend. Some people go immediately to the complex. Immediately, what is the most wowie thing I can do, the thing that's going to create the biggest splash biggest bang for my buck kind of thing. I recommend not doing that. When you start simple, you get an education. You understand the simple things, and then you can go on to the more complex things a little bit at a time. So that when you get to the end and you've got this design that is more complex, you understand what everything is doing. You understand why there are trusses. You understand why we use a suspension bridge, or why we're using a truss bridge. When you just go to the end result, you don't know why, and so you make little mistakes, petty mistakes, that have huge consequences. You forget to do some little thing because you didn't understand why it needed to be done, and then the whole bridge collapses. Okay? Then we move on to generating alternative solutions. Right? So what are we've researched all the possibilities. What are the ones that we actually want to use? And why? That's where we generate our alternative solutions. We're going to have some kind of process for deciding that. And then once we've decided, we will come out with one solution, our best solution, that fits our problem up here the best. Then we start to model and prototype. We start to build up a first run, right, which is usually what we call the prototype. And then we test it. We test it and evaluate how it does. And if it works out, that's great. If it doesn't, then we kind of have to start this process over. Now here it shows it as a cycle. But sometimes you test and evaluate and you find out that maybe one of your other alternative solutions was really your better solution. So maybe you can skip from here to here and pick another solution and start from there and then build a new prototype. Or maybe you just need to come down here to your best solution and alter it just a little bit. And then just alter your prototype and come to here. So you can skip from one of these steps back to any previous step and start from there and go back around again. That's one of the reasons they show it as a cycle. Right? And then you can start over again and you can improve it. Or you can start over again and change it. You can do all kinds of, that's a very simple representation of the engineering design process. In my Engineering 1010 class, this is a much more complex process because we're doing a lot more with the design process. We're trying to be more detailed with it. And it really, all it comes down to is just a lot more effort. We put a lot more effort into the design process. Here is a great tool that you can use. I think that this is still, we'll check this website, see if it still works. Where you would use this tool is right here in the generating alternative solutions and to choosing your best solution, and even into this prototyping and modeling part. So West Point Bridge Designer, let's take a look and see if we can find it online here. So here they have a bridge design contest, and a lot of engineering schools have design contests, and a lot of them are bridge design contests. And I have a friend that's at a university that just went through one of these contests. And this particular one, we have this bridge designer software that we can download for free, and we can design bridges that fit our specifications, our 2 feet span, our 2 foot span with a 20 foot or a 20 pound load on it. And so you can use this to help with this. There are also several apps for this, for the iPad and for other devices. And some of them are better than others. Some of them allow you to change the specifications and be more, I guess personalize it more. Some of them don't allow that so much. But there are a lot of different things that you can use, and that is when you're using a computer to build something, that's what we call the modeling phase. Modeling is kind of like indirect design. You're not designing something using real materials or real sizes. It's indirect design. And of course, our full-scale model will only be 2 feet long, so we'll never really get to the full design process. But that's some software you can download. I'm not sure if it's available for both Mac, and it is available for Windows and Mac, so you can have it in 2 different versions. 3 versions for one that has Java already installed. So you do have that option. Did you raise your hand? So that is something that you can use. That's kind of nice. And here is where we get to the part that you are going to start figuring some things out. Last time I did the 18-inch gap and 2-pound load. It was just way too easy to do. And so we want to make it much harder. We're going to do the 20-inch gap and we're going to do the 20-pound load. 20-pound loads, that will really kind of it'll make things rough for you, I promise. You'll have a lot of designs that will not quite make that, not be able to handle that. But anyway, that's why we do it. Make it a challenge for you. But right here, your problem statement, this is the first place where you're actually supposed to fill something in. And what I'm going to do is I'll send this to you, or I can print it off for you, either way. Now that I've got everything up and running in my computer in my own room, I can print it off for you. And you're actually going to write directly on this worksheet. What is your problem, right? I need to build a bridge, and it needs to support some weight. Whatever your statement is going to be, that's for you to fill in. And then here you're going to change the 18-inch gap to a 24-inch gap and a 20-pound load at the center. Right? Here are the testing criteria, I guess you could go. Maximum deflection is reached if a bridge deck bends over 13 millimeters or a half an inch. I will probably be a little bit more, I'll probably give you a little more leeway there, probably more like an inch, maybe even a little bit more than that because of the 20-pound thing. But if anything breaks on the bridge, even a little bit, then that's going to be considered a failure, right? So, and then we move on to some ideas to help you out. We've got your basswood dowels that can be used. The drill bit that I've provided, that I think I provided, is just the same size as the basswood dowel. So as you drill out the hole, that dowel should just barely fit in there, fairly tight, but it should fit in there. You might have to ream it out a little bit. I gave you a little red-handled reamer that kind of smooths things out, cleans it out, and also the dowel will fit in there. But notice here that the dowel goes through these different members of the bridge, and then it expands out to the other side. That's going to give it lateral strength so that the bridge doesn't twist and turn when you put lots of forces on it. Now, consider also while you're building this bridge that the width of the bridge is going to matter. The wider you make the bridge, the less stability it has. So you don't want to give a lot of width to your bridge. Also, there's something else that I want you to remember, that I want you to realize. And that is that if you look at a bridge, there's something really quite interesting that you will not see in our wood. Let me see if I can zoom in. Let's go to a bridge online here, and we'll zoom in on a picture. So if we take a look at a truss bridge, let's look at images, not videos. There we go. If we look at a truss bridge, you look at for example, just a picture, just a drawing of one, it just looks like lines. But if we actually look at the bridge itself, and we look up close, this is a fairly big image, notice something about the iron here. Is it just a rectangular piece of iron? What do you notice about the top and bottom of this piece of iron here, for example? And you can even see it in some of these. What's that?
Round?
No, it's not exactly round, but it's got a flange on it. It's essentially what we call an I-beam in engineering. I-beams are extremely strong. And the reason is because they are transferring a lateral force into a vertical force. or a force on top of the beam. If the beam is sticking this way, like in this picture, a force that's coming down on the beam this way at any point is transferred into a lateral force within the beam. Okay, by making this shape in the beam. The reasons for that are a physics reason. You don't necessarily need to understand why. Essentially, what it comes down to is breaking a piece of wood like this. Just taking a piece of wood and breaking it over your knee is quite easy compared to trying to pull on it on both ends and breaking it. And that's what it comes down to. And these forces are all transferred into push and pull forces within the beam, and that's a very difficult thing to break in that direction. So I-beams would be a really good thing to use. You say, well, you didn't give us any I-beams, teacher, but I did. I gave you components to make I-beams. Now, not everything in your bridge needs to be made from an I-beam, but some of the components that are going to be stressed the most, for example, lateral beams along the bed of the bridge, you might consider making out of I-beams. You might consider gluing together some wood and making some long I-beams. You're going to have to overlap the wood and make it, make them so they're 24 inches long plus. But you may consider using I-beams in those portions of the bridge because they're extremely strong. Okay? So just a thought as you're thinking about how you're going to do this project. So, you have basswood dowels so that you can connect these different members within a truss. You have wire cables or you have string in our case, that you can use to hold these things closer together to keep that also essentially transfer some force into a different direction, into the string. Of course, you can cut these things, glue them together, drill them and everything else. Make sure that when you're drilling through the wood that you're drilling right through the center so that you have the strongest connection possible. And then these connector strips can also be cut. They can also be bent, which is kind of nice. And you can even cut them at the holes so that they'll bend even a little bit more. But you do have only a limited number of those, so make sure that you don't use them until they're all used up. Also right here they give us a clue that you can, in many cases, you can actually put your structure together without gluing it together entirely, so that you can make sure that you like how it works, you like the way it's coming together. And then take it apart again, glue it, and put it back together so that it's all glued together, so that you're not having to try to break apart things that have been glued together and you don't like your design, the way your design comes out. So, how do we come up with our alternative designs? We've got our problem now, and now we need to figure out what kind of designs we can build. And this is where you're going to start to brainstorm and sketch out some ideas. Get some scratch paper and get online, and you want to start looking at the different kinds of bridges that are out there. There's lots of different ways you can do things. And then we also provide for you some graph paper. That's at the very end of this thing. If we go to the very end, there's alternative bridge design. There's an alternative bridge design sheet. You have a top view, front view, and top view, front view. Do they do a side view? No. I guess the front view is the side view. So you have a top view and a side view. So the skinny one is for the top view, the big fat thing here is for the side view of your bridge. And here they only show it for negative 24 centimeters, positive 24 centimeters. Why don't you just consider each one of these two box sets here an inch, and then you're 24 inches long, right? And you need to go an inch extra on each side, and there's still a little bit extra on each side, so you're good there. And for each one of these designs, each one of these alternative designs that you're going to build, and there's a sheet for 3 of them, I think. For each one of them, you're going to try to score them in terms of, do they meet the design constraints? Are they 24 inches long, right? Do they use parts that I have, that kind of stuff, right? And then you're gonna score them for their functionality, for their aesthetics, and for their economy, right? So economy would be, are they using too many parts? Are they using fewer parts? Score them out of 10. And you're essentially going to compare 3 designs. Here's another alternative bridge design. Another alternative bridge design. So you're gonna find 3 that you like, and you're gonna compare them using this scale over here that's at the bottom of each page, right? And meeting design constraints is the most important, so it has the most value. These other 3 may be less important, I guess, so that they have less value. But you're going to decide which one is the best using these kinds of things. The function essentially being how functional will it be. Obviously, bridges that aren't flat won't be very functional. Bridges that have things in the way of the road bed won't be very functional. Bridges that are really tall maybe won't be so functional. Aesthetics, how nice does it look, essentially? And then economy is how many parts are you using to build this bridge. And then you go on to choose the bridge that you're going to use from those 3 scores. You're going to essentially pick the one that has the best score, and you're going to go ahead and build that bridge. But you're not going to just build it. You need to first plan how you're going to build it. I need to know exactly how many pieces of wood you're going to use, what length is going to be each of those pieces, if they're going to have, well, this is the length here, if they're going to have holes in them, the distance between holes, and the number of holes you might put in it for each piece of wood. Here. The same thing for each piece of plastic that you're going to use. You want to know exactly how many you're going to use, and you're going to number each one of these on the drawing so we know exactly where each piece goes. This is a process that engineers have to do because they have to be able to explain to the construction workers exactly how to build what they engineered. They can't just throw a drawing at them and say, make this. They have to know exactly what they need. This is particularly important with bridges because bridges use huge parts. And you can't just say, well, I'm building this part in 30 minutes. I need a 40-foot long piece of steel right now. You can't just cut that. They're made to order. And so those things have to be known months in advance. In the case of suspension bridges, they build the cables on site. They actually forge the cables while they're putting them on the bridge, and all at one time. And so they have to bring the correct machinery and the correct amount of steel, and they have to have the right dies so that they're making the cables the right sizes, with the right twist. It gets really complicated. You guys don't have nearly that complex an operation, but you still need to plan. Same thing for the dowels. What dowels go where? You have to number them on your design sheet, and then you should say exactly how long they need to be. All these things need to be planned. Same thing for your string. And then here is your final design sheet. Again, this is metric, but since we're doing inches, you can go ahead and convert it to inches, and that's fine. But they've given you sheets here that you can design your final layout. They've given you several sheets, so you can make it as big as you want. You can copy those and paste them together to make a big sheet if you want. However big you need it to be. It should be in color. So 3 different colors, meaning you have essentially 3 major parts on your bridge. You have your wood pieces, you have your plastic pieces, and you have your wood dowels, right? And then you can use something else for your string or your wire or whatever. But all of these things should be in a final design sheet that has all the things numbered on it, and everything is to scale. So if it's going to be 2 inches in real life, it should be 2 inches on the sheet and everything else. It's a major process, and we haven't even started building anything yet. All we've done is we've drawn 3 designs. We've decided which one we're going to use using a criteria process, and then we've created this huge drawing that's very detailed with all the parts numbered and labeled of the design we're actually going to build, right? Here they actually are going to do what is essentially like a computer test, except we're going to use our brains, right? So this is a model. We're going to make a model of our bridge, and this is actually what they're using their pencils for. Now that I'm remembering how they do this. In this one, they're actually going to use their pencils after they draw their design in just regular pencil. They're going to use their colored pencils to decide which ones of these members are going to receive stresses and how they use it. They call it tension and compression. So in other words, which ones are going to be stretched and which ones are going to be squashed. So the ones that are stretched are the things that are going to feel tension, and the ones that are going to be compressed are the ones that are going to be squeezed. So if you have a load right here on this bridge, what things will be compressed and which things will be stretched? Well, obviously the road bed, if they press down here, is going to get longer, so it's going to feel tension, it's going to be stretched. And these things are going to be stretched, I think, but the top of it is going to get pushed down, so these things are going to feel some compression. You can kind of get a feel for how things are doing just by thinking it through. And we're not trying to make you learn any kind of intense engineering skills here, but it's essentially just what we think will happen, right? Then they want us to kind of figure out where this is going to, where we think it's going to break. In this one, they're talking, in step 3, they're actually talking about pressing on the actual bridge. And so you could actually do this after you build the bridge as well, but you should do it before and after. So anyway, we've done, so in section 2, we've marked these different things for which ones we think are going to get compressed, which ones we think are going to get tension, and then in step 3, we're actually going to build the bridge and put some stress on it, just with our hand, right? And we're going to record everything. This is important about engineering. We record things. Which members of our bridge we think will fail, which members we think are going to be compressed, and so on and so forth. And then we go back and we improve our design for our bridge. We've built our bridge at this point. We've tested it in our mind. We've tested it with our hands, just pressing on the bridge, and we think, well, before we test it to failure, let's try to improve it. Let's try to maybe increase our strength in a particular place, and maybe add some more members in, maybe add some more wires in, maybe add an I-beam here or there, and we'll revise the bridge, make a new drawing, and they give us new sheet to do that again, and then we go ahead and evaluate it again to see if it's better, and then we're going to finally test the bridge in the end and see how much weight it can hold. For those students that are not here in North Platte, that will be done on your own with a video. You'll build your bridge, you do all this stuff, and you'll take a video of every time that you test it, either just with your hands or with actual mass. You'll take a video of that test and describe to us what you're doing so that we can watch it here in class. For those of us here in class, we will do that in class, and we will be, of course, recording it so that we can show the students who are out there in Sargent. We just have one student in Sargent. At the end, we'll calculate the design efficiency of our bridge. We have to calculate how much we used of each material. We have to know our ultimate load capacity, which was the amount of weight we put on it before it broke. And then the dead weight of the bridge. We need to weigh the bridge when it's completely built. And then we have these concluding report things to do as well, where we're going to essentially write a little paper about what we did and have some data in there, some tables of data, a list of the parts we used, all the information about the lengths and everything else. And they give us some good outlines on how to put this together. The final evaluation is right here. Does it meet the design criteria? Performance, aesthetics, craftsmanship. How did I participate? This is usually written for a group, but we're going to do it individually. We do a report and the total points out of 100. You guys will actually fill that out for yourself to tell me how you think you did on this project. And then I will go through and review all the stuff that you've done, and I will fill it out. And then we will give you a grade. Believe it or not, this part will figure into your grade, in my part. How you fill this out will be right here in my estimation of your grade. Now, like I said before, this class is not intended to be difficult. It's not intended to challenge you intellectually. It's intended to give you some experience with engineering so you can decide whether or not you like engineering, whether or not it's for you. And so, once again, I'm not really trying to tax you. This should be fun, enjoyable experience for you. But I do expect you to put in some time and some effort, right? Some time and some effort. So in class for the next week, today, Wednesday and Friday, I will give you time to do your research, to figure out your designs, to start your designs, and so on and so forth. By the end of this week, you should be spending time on your own starting to build it. So by Wednesday at the very least, you should start building. You should have been done with all your pre-design, and you should be starting to build this on your own, in your own time. You will not build them in class because this classroom is not really designed for making a mess in. But if you want to, scoot over to the physics lab, we can do some stuff over there. But you should be spending time at home, probably at least a couple of hours this week, a few hours maybe this week, building your bridge and starting to test your bridge. Because it will be next Monday, I believe. I think we have a week set aside for this. Take a look at that. So it'll be next, I guess we gave from the 10th to the 17th, so today is the 15th. So yeah, so we'll go until the 22nd, so we're pushing everything down a couple of days. We'll go out until the 22nd, so next Monday, we will have those bridges in class, and we will be testing them in class with 20 pounds of weight over a 2-foot span, videotaping the whole thing, and that's going to kind of be where we're at. Everything between now and then is going to be kind of on your own. I will be going over at the beginning of each class on Wednesday and Friday kind of where you should be at. Okay? So at Wednesday, you should be at the stage where you have researched your project, you've gone through and decided which one you're going to do, which design you want to use, and you've drawn that design and you're hopefully starting to build. And you can start testing. By Friday, it should be built, and you should be testing and thinking about improving. And so those are the things that I'll be checking, that I'll be showing you, that I'll be going over a little bit in class on Wednesday and Friday, and I'll be checking up with you guys to see where you're at, help you along. But there are things that you should be doing. You should be making your drawings. You should be filling out those evaluations of those designs. You should have a list of the parts that you need to cut out. You don't do that after you do it, after it's built. You do that before it's built. Okay? And those things should be, you should be working on those on time. And besides that, that's all I have for you today. So today, you can go ahead and get started, and I'll go get some print-offs for you of this so that you can have it printed. And we'll get you started. Yes, sir.
What's the mass, or what kind of way to use them, like how wide?
It will just be a hanging mass. It will hang from the bottom of the bridge, probably. If it can sit on the bridge, I'll just sit it on the bridge. If the bridge can't accommodate it very easily, then I will just hang some masses from the bottom of the bridge. That's the easiest way to do it. So, good question. Any other questions? I know this is a lot in one day, but we will review some things on Wednesday so that you kind of know where you should be at, and you can get there if you're not there already. And we'll do the same on Friday, but then next Monday we'll be in here testing our bridges. Okay, if there are no more questions, then I will go over to my office and print these things off. You guys can go ahead and get started researching. If you don't have a computer, I can get you over on a computer in my physics lab. I've got computers in there. I've got to go get a key for my physics lab because I forgot my keys this morning. But I will go do that, and then I will be right back up to my lab in a minute. We'll end this now. And also, Charlie, the homework assignments at the beginning, I will explain those to you in my office in just a minute.
All right.
So that you can get those caught up real quick. They won't take you too much time. I'm going to keep your key.